Hello. Today I wanted to briefly discuss what is TCP IP. First, IP or Internet Protocol is an addressing system that is used throughout the internet. It is what actually allows machines to communicate with each other through source and destination IP addresses. TCP is a protocol as well that is responsible for sending and receiving data in an orderly fashion. It allows the data that we want to send, say from an email message, to be broken into packets, smaller data transmission chunks and or units. And then we give that information after it's broken down in the packets to the internet protocol layer, which will then is responsible for transmitting that information to the destination source IP address. So it is used primarily in combination to allow successful transmission of data between two entities. If we look at the network protocol IP packet closer, we would see information like a version, a header length showing how large the packet is, the type of service. We would look at the total length of the packet, and then we would also look at some flags as to fragment or not fragment this. We also would look at a time to live, which is an important part of the packet information, because we don't want information to last forever being transmitted over the internet. And then finally, the most important part is the source IP address and destination IP address. These are addresses that are critical to delivery of information. This is how it would look in a packet diagram. And here you can see where it's layered, that information is put together. Similarly, for the TCP packet, it has a source port and a destination port. These are primarily important because they identify the type of service or where a particular service might be residing and listening for inbound traffic. Sequence numbers allows you to reassemble the information that's been broken down, and then acknowledgement numbers allows you to securely transmit and keep the packets in order and make sure that they are successfully transmitted without data loss. Finally, TCP also has some control flags, which we'll look at in another video, that allows you to establish the connection and tear down the connection. TCP is connection oriented, where IP is connectionless. So these work together to safely transfer data. And this is how the TCP packet would look, where source, destination, port, sequence, acknowledgement number, and some other flag information. Finally, some frequent information that is needed, like, as I said, the packet and the payload, which is combined together to send information to and from a source IP address and a source port to a destination IP address and a destination port. And this is TCP allows for a reliable sequence transmission of data. And we'll look at the significance of the flags, but it allows controlling of the message and how it's fragmented and etc. So this is all we have. Let's look quickly at a Wireshark capture of data, just to show you how it looks in real time. So here with Wireshark, if we look at our transmission and we do a filter of TCP, then we'll see TCP packets being transmitted. So if we look at one in particular, let's just grab one. Here you can see the stacking that we talked about, the frame. This is the transmission lower level. Then you have the internet protocol, which has the various version and the information as far as the source IP and the destination IP. And then on top of that resides the source port, the destination port. It has sequence numbers that we talked about, and then control flags, which we'll look at. These are used for pushing of the data and receiving of the data and the control of the connection. Okay, that's it. I wanted to show you in this video. Thank you very much for your time. Hopefully it was helpful.